All right, we are on day 6. Homework for tonight. You're going to be in the pink packet for multiple choice, doing the 2003 multiple choice, numbers 1 through 14. Those are no calculator questions. And we're starting a new free response, 2019. You're doing questions 1 and 2. And those are calculator ones. 1 and 2 on the free response are always the calculators. 4 through 6 are the no calculators. So here are your multiple choice answers. We're going to pause the video for 3 minutes for you to check those, and then we're going to go through all of them, and then we'll do the free response ones as well. So we're going to pause for 3 minutes, check each of those answers. All right, so in number 1, we've got a limit. When you do direct substitution, you get 0 over 0. So do your derivative. Careful with the sine 2x. You've got to do a chain rule, a times 2 afterwards. Then do direct substitution again. You end up getting 2 over 2 pi, which is reduces to 1 over pi, so choice B. In 2, limit as x goes to infinity. When x goes to infinity, only the biggest powers are really going to matter. So you don't have to worry about the plus 1 on top or the minus 3x plus 5 on the bottom. So just think of square root of 9x to the 4th. That's absolute value of 3x squared. And on the bottom, we just worry about the x squared. Well, because we're going to positive infinity, that absolute value, we're just going to think of as a 3x. So this is still as x goes to infinity. So we'll just think of that as 3x squared on top. So then ratio would just give us a 3. And number 3, we want to be continuous but not differentiable. So the vertical tangent, corner points, and discontinuities are the places where you're not differentiable. Of those, the ones where you are continuous are the vertical tangents and the corner points. So we would want it -2 and 1, so choice C. In 4, start with your volume of the sphere formula. Notice we've got a rate in terms of time, so we want to take our derivative with respect to time. So we'll have dv over dt, 4 pi r squared, but then you got to do times the dr over dt. The 2 pi cubic meters per hour was decreasing, so when you fill that in, you've got to fill it in as a -2 pi. We wanted the instant that the radius was 5, so fill that in for r, and then work to get dr dt by itself. You get -1 over 50 or -0.02 if you did it in decimal form. But we wanted to find the rate of the surface area. So do your surface area formula, 4 pi r squared. Take the derivative with respect to time again, so 8 pi r dr dt. We know dr dt from the first half of the question. Fill in the 5 for the radius, and you eventually get your rate of change for the surface area is -4 pi over 5. Now, the reason we do not have -4 pi over 5 as a choice is in the question, they already specified that it was decreasing. So by saying that it's decreasing, they're already implying, saying, okay, this is going to be a negative rate. Which of these negated would be that rate? Here was our slope field one. Notice your scale. You have 3 and -3 on the y-axis. So this is really 1, 2. This is -1, -2. So the main thing that stands out is y values of -1 should give you slopes of 0. So when you put -1 in for the y's, in A you get -x plus x, which is 0. So that's still in the running. In B, when you put -1 in for y, you get -x minus 1. So that's not in the running because it didn't give us 0 back. C, when you put -1 in for y, you get -1 plus 1, that's 0, that's in the running. And then in D, there's nowhere to put a -1 in for y, so you can't possibly get 0, so that's ruled out. Then notice that we also have a slope of 0 when x is equal to 0. So 0 in for x in A, we get back 0, so that's in the running. There's no way to make C be 0 when x is 0, so that's ruled out, so it's got to be choice A. And for our last one, So first off, let's start with 3. That's the easiest one. I have a picture of our piecewise function there. At x equals 3, we are not continuous. Because we are not continuous, the derivative at x equals 3 does not exist. So that rules out choice 3 right there. Now, what we need to recognize the other two are showing us, they're showing us the h-way definition of the derivative, but only from one side. So the definition of the derivative is happening at x equals 3 in what it's displaying there, because that's like in our x plus h and f of x, the x spot is a 3. So what the first one is saying is when you do slopes a little bit to the left of x equals 3, let me word that differently. If you do slopes using one of the points as 3, so 3 comma, whatever we have, 3 comma 2 I think it is, and the other point, we want h to be a little bit negative. So think of it as like 2.9 comma question mark. And when we make those 2.9s be closer and closer, like 2.99, 2.9999, and so on. The other one, we're using 3 comma 2 for the 1 point because of this one. And then the other one, h is a little bit bigger than 0. So we're using like 3.1, 3.01, and so on. So what those choices are saying is, as your point keeps getting closer to x equals 3, is the slope approaching 2? So let me start here. There's like a random point left of x equals 3. Let me connect it. That slope is negative. Now let's get the point a little bit closer. Slope is still negative. Let's get super, super close. Slope is still negative. No matter how close we get that point on the left side of x equals 3, the slopes are never going to be approaching 2. So choice 1 is ruled out. However, on this side, if we pick something a little bit right of 3, connect it to 3, 2, that slope is 2. If I get closer, connect it, that slope is 2. If I get super, super close, connect it, that slope is 2. So those slopes are approaching 2, so we would just have choice B. So that one is a bit of a tricky question. Moving over to 7, we want to do the derivative of an integral that goes from a number to an algebraic expression on top. So when we do that derivative, we fill in the x cubed for t, but then you have to multiply by its derivative afterwards because of chain rule. So fill in the x cubed, multiply by 3x squared, now put in 2 for all the x's, and you end up getting choice D. In 8, we want to write our integral as the limit way we saw it before. Well, start off, we want to do b minus a over n, and that gives us the base of each of our rectangles. So we'll have 5 minus 3 over n, or in other words, 2 over n. That gives us our delta x, which again is, when we did Riemann sums, was the base of all of our rectangles. When you're doing a rectangle, it's the base times the height. The base was always delta x, and this height was coming from a y value, so it was f of something. Well, we can eliminate choices C and A because they don't have the 2 over n at the end for the base. Now, the other part, you're always doing subbed into your function, so subbing into x to the fourth, you're doing the a value plus delta x times whatever variable is at the bottom of your summation. In this case, it's k. So we want to do here f, the bottom of our integral value is 3, plus our delta x was 2 over n times k. So we want to sub that into x to the fourth, so we should have 3 plus 2 over n times k all to the fourth. And the choice that looks like it has that is D. Going on to 9. 9 asked for average value. Average value, you do 1 over b minus a integral of whatever thing you're trying to find the average value of. So we wanted to find the average value of f on the interval from -4 to 4. So 4 minus -4 in that denominator gives us the 1 over 8. Well, now this part is just saying, find your area from -4 to 4. So if we go down here, our first area, that triangle is a 1. This would be -3 because it's below. This part here is a 2, and that's a 1.5. So we basically have 1 minus 3 plus 3.5. Do that all out, you eventually get the 3/16 for choice B. In 10, the easiest way to do this is to recognize that that is our differential equation of an exponential function. We saw the basic setup for that was c times e to the kt. If you didn't recognize that, you'd have to do the work I have on the left and do it as a differential equation where you get the y's on one side, t's on the other, and then do your integrals of both sides and so on. But the quicker way is to recognize it's exponential. So now just sub in your 0.04, you get c is 4. Now from here, sub in your 0.212, and you get that k eventually is 1/2 natural log of 3. So fill those in for c and k, and we've got our equation, which in this case looks like it is choice A. All right, our graph given to us is f prime. All of these choices are f's. The key phrase to remember is slope in f equals y value in f prime. So our y values from 0 to 1 in f prime are negative. So we're looking for something that has negative slopes from 0 to 1. Choice A has negative slopes from 0 to 1. Choice B has negative slopes from 0 to 1. Choice C has negative slopes from 0 to 1. Choice D does not have a negative slope from 0 to 1. Then we should switch to positive slopes all the way from 1 to 4. Choice A has positive slopes from 1 to 4. And I should mention there's a brief point at 3 where the slope is 0 for an instant. So we have positive slope, brief point slope of 0, positive slope. So that seems reasonable. Oops, and I said to 4. This should actually go to 5 because the y values were positive all the way to 5. So that seems to make sense. So here we have positive slopes, positive slopes, positive slopes. But then between 3 and 4, we start having negative slopes. And we were supposed to still have positive slopes all the way till 5. So that's ruled out. Now in C, we have positive slopes for almost all those spots, except for x equals 2 and x equals 4. If this was our original function, our derivative would not exist at 2 and 4 because there's discontinuities. But if we look at our derivative graph, there are actual points at 2 and 4, meaning the derivative does exist. Now, if we went to the second derivative, we would see in our second derivative graph that we would have things not existing at 2 and 4 because the corner points in our first derivative graph. But because the derivative graph exists everywhere, we shouldn't have any discontinuities in our original, so we get choice A. In 12, they give us the equation for f prime. We want to know when the original function's decreasing. The original function decreasing means the derivative is negative. So just graph that function they gave to us and see where it is negative. And I should say to note, starting at question 11, you were able to use your graphing calculator. What's the meaning of h prime of 5 equals 2? Well, h prime is a rate. The time is t, so we should have something about a time being 5. And the 2 is a rate, so we should have 2, and our units should be something per something, because it's a rate. Now, rates are always the y units per the x units. So it looks like our y units here are degrees Fahrenheit, and our x units is minutes. So we should have something about a change in 2 degrees Fahrenheit per some type of minutes. So if we scroll through, this is saying our units is just 2 degrees Fahrenheit. Well, that's not correct because it should be a rate. Same thing here, 2 degrees Fahrenheit. This says it's a constant rate. Well, we don't know of 2/5, and we know it can't be a constant rate of 2/5 because our rate is 2. The last one says the temperature is increasing at a rate of 2 degrees Fahrenheit per minute. So we got our units there, and it's happening 5 minutes after it's adjusted. So that's the one that matches with what we want. In 14, if we want derivative equal to 0, you've got endpoint y values equaling each other. We want to think Rolle's theorem. We've got continuous on a closed interval. F of A is equaling to F of B. In order for Rolle's theorem to be true, we need to also know it's differentiable on the open interval. So that would be choice C. And 15 is just a calculator one. The thing we know is 1 hour we're 0.75 feet, so this is an accumulation function. So we are already at 75, plus what are we adding on the interval from 1 to 2? And put your function in there. So this would just go in for R of t, put it in the calculator, see what you get, and it looks like it ended up giving us choice D, the 2.111 feet. All right, moving over to free response. Oops, nope, I guess there's one more, 16. So in 16, we've got an acceleration. We're braking at time t equals 0, and our velocity was 80. So in other words, we know that v of 0 is equal to 80. So you can take your acceleration function, and v of t would be the antiderivative of that. So it'd be negative 2t cubed minus 1/2 t squared plus c. But then using this point to resolve the c, that's where we're getting this velocity equation. We want to know, how far does the race car travel? Well, we would want to graph this velocity function and see when's the first time the velocity hits 0, because that would be representing when the car stops. We end up getting that it's at that value of t. So then just do your integral from time 0 to that of your velocity function, and we end up getting the 198.766. Now, this particular velocity function, it was positive the whole time. If you had some type of distance traveled question over an interval and you had some positive velocities, some negative velocities, you would have to split it up and do it separately. But because we had positive velocity the whole time, we just had one integral we had to do. All right, now the free response. So start with your volume formula for a cone. We'll do our derivative with respect to time, because we want the rate the water is changing at a specific time, so we want some meters cubed per hour. So we got dv dt equals pi h squared times dh dt. Fill in the 25 for h that they told us was the t0 height. And then dh dt was a little weird compared to what we've seen. Usually they tell us dh dt. dh dt is the same as saying h prime of t. Well, they gave us an equation for that. So we just need to fill in the 0 for the t's in that, and that will give us what our dh dt is. Now, if you had done that off to the side, that would have given you 24 over 4, 6. So that would have been like -4 in that parenthesis there. So you might have simplified that and just had -4 in that spot. But put it all in, round it to 3 decimal places on the left, or if you kept it in terms of pi, you have it in the box there. Now, it did not say that it had to be exact form, so I guess I should have boxed this as well. Either of those 2 boxes would have been correct. What's the minimum height? Well, we want to look at the derivative of the height, which is the equation they gave us. These were calculator questions, so just graph it on the calculator. We've got our interval 0 to 2, or 0 to 24. Find from the graph, when does this h prime of t function cross 0? And it only did it at that 6.26 value or whatever. Put your negatives and positives appropriately. Well, when the derivative switches from negative to positive, we get a relative min. And take that value of t. Because we had a closed interval from 0 to 24, we've got to check our relative min and both of the endpoints. Well, we know at h of 0 is 25 meters. They already told us that. Take our relative one, our accumulation function. You start with where we are currently, and then do your integral of the time period that you're adding on. Same thing for the 24. Started at 25. This is 0 here. Do the integral of the time period we're adding on, and then look for the one that's the smallest overall, so we get the 16.339. Notice I kept this out a ways because we want the final answer to be rounded to 3 places, not that t value. And the last one, we wanted a tangent line approximation. So we need an x, we need a y, we need a slope. Well, our x is essentially t equals 16. We could do the process that we did in the question above to find the y value. So 25 you're starting with, integral from 0 to 16. And then sub 16 into our h prime function to get the slope. So here's our initial equation of a tangent line. They wanted us to know the value of t when y was 25. So put the 25 in for y, work to get t by itself, round it to 3 decimal places, we had 17.258 hours. And moving over to the last one. So if g is the antiderivative of f, that means f is the derivative of g. So if we want to know where g has a relative max, we're looking at its derivative graph, so in other words f, where it switches from positive to negative because we want a maximum. So looking at that graph, it only switches from positive to negative when x is equal to negative 2. Concave up, we would want g's second derivative to be positive. So that means we need f to have a positive slope. So that would be on the intervals -1 to 1 and 2 to 3. So you can either say because f or g prime is increasing, or you could say because g double prime, or in other words, f prime would be positive. Either of those explanations is fine. Sub in 0 for x. On the bottom, we get 0. For the top, we got to do a little calculation. So to find g of 0, the thing they told us in the question was that g of 3 was 7. So we do 7 plus the integral from 3 to 0. Well, 3 to 0 we don't like because we like the smaller number on the bottom, so flip it and put the negative out front. So we're really doing 7 minus our space from 0 to 3. Well, based on what they had told us in the question, they told us that this space was a 5, this was a 4, this was a 5, and this was a 3. So if we're going to 0 to 3, we would have a 5 plus a 3 in that spot, so it ends up as 7 minus 8, so -1. So that gives us this -1, which leads to a 0 in the numerator as well. Do your L'Hopital's derivative of top and bottom, you get g prime of x over 2. So we're going to do g prime of 0. G prime is just f. F of 0, just look and see where's the graph at x equals 0. Well, it also happens to have a y value of 0, so you get 0 over 2, or in other words, 0. And your last one, d. So we want to do the integral of that function, h. The first part of it is going to require a u substitution. The 4 is not. So I separated my integrals. This first integral, antiderivative of f is g, but you've got to do a correction by a half because of the u substitution. Antiderivative of 4 is 4x. So I just went, I thought of it just as a rectangle and did the area of the rectangle. Or you could have done 4x going from -2 to 1. So you would have 4 minus a -8, So that would give you the 12 that way. But I just thought of it as, oh, okay, if it's a constant 4, that means the height is 4 and the base is 3, so the area is 12. Over in the other one, sub in your 1, and you'll get g of 3, which they told us was 7. I just pulled my 1/2 out front. And then sub in the -2, you'll get g of -3. Well, we don't know that value yet. So go off to the side, do an accumulation function. At 3, we knew we were at 7. We want the lower on the bottom, so flip them and put a negative out front. And now do the areas they told us, the 5, the 4, make sure it's below so it's negative, and then the 5 and the 3. Neaten it up, you get -2. And when you neaten everything up, you get 51/2 or 25.5. All right, so the rest of the period, you'll work on the next free response ones that the sub directs you to, and there'll be answers posted on the whiteboard for you to check your answers as you're doing them. And then you can do the homework if you finish those couple questions. Have a great rest of your day.